Hi folks, we're going to take a look at page 143, number 13. So here they're telling us that these boxes are created using a rectangular piece of cardboard, okay? And they tell us that you're folding on the dotted lines in order to create the box, okay? So you have to think that this portion here is going to be flipped over. Okay, so that's going to end up being the top of the box. This here is going to be the bottom of the box. And then these side flaps are being folded over. So in other words, the height is just going to be this little portion here. Okay, so the first thing I'm going to do, given that I'm looking for the volume, is I need to figure out what the length, width, and height are. Okay, so I would say the easiest one is going to be the height because it's going to be this little portion that's going to be folded over. So we know that the height is going to be equal to x. Nice and easy. All right. I would say the next easiest one is going to be this width here because, again, we see that this portion represents the top of the box. And this represents the bottom of the box. So the width we see is just given by 20 centimeters minus these little two pieces that we're folding over to get the height. So in other words, the width is going to be 20 minus 2x. All right. Let's take a look at the length of the box, which is going to be this part here. Okay. And the first thing I notice is I have two equal portions. Okay. Because the top of the box and the bottom of the box clearly have to be the same. And this length of x is the same as that length of x. So if you look here, from there to there, I've got 1/2, and then I've got a 2/2. So I'm just going to focus in on this portion here, okay, up until that dotted line. So if that's half the length of the cardboard, it means this is going to be equal to 18, half of 36. So the length is just going to be 18 minus this little portion, which is x. And there's my length, 18 minus x. All right. But of course, now that we've got the three dimensions of the box all written in terms of the same variable, I can now write a function for the volume. So the volume is given by x times 18 minus x times 20 minus 2x. Okay, and there we go. So there's part A. So it's about understanding how this box is built, and then from there, finding expressions for the height, width, and length. All right, now I'm going to go to B. Now, I had told you that this one here will need technology. And in fact, even though the book didn't specifically say that, the fact that they're saying to the nearest tenth, we should be interpreting that as meaning that these are not going to be nice integer answers. All right. So if I want to solve this problem, all I have to do is replace v by 450. Okay. And now I've got my polynomial equation that I can solve. Okay. Now, normally what I would do is I don't have 0 on this side of the equation. So the fact that this is factored is not of any use to me. I'd have to distribute all these terms, bring the 450 to the other side, and then I'd have an equation with a polynomial expression equal to 0, and then I'd be able to factor and find the answers. All right. Since I know it's not going to work, since they've kind of indicated to me that this is probably going to, that this is going to need technology to solve, I'm not going to bother doing that. But that's what we would do if it could be solved using factoring and the factor theorem. All right. So good opportunity to show you a couple of ways to do this here. Okay. So one thing you can do is, and I'll go to Desmos. Okay. So if we go to Desmos here, I can just input my equation, okay? And instead of inputting the equation, all right, let's go back. I should have shown you this here. What I'm going to do is I will, whoops, sorry about that. I will take the 450 to the other side. The reason is it's a lot easier to read x-intercepts off Desmos than to figure out where this right side is equal to 450. Okay, so just to let you know what I'm going to be doing here. So let's go back to Desmos, and what do we have? Well, we've got x times 18 minus x times 20 minus 2x. Okay, and then remember I'm bringing the 450 to the other side, so minus 450. And here I see that I've got more than one x-intercept. All right. So remember that I'm interested in when this is equal to 0. So I see that one of my answers is, let's say, 1.65. So I'll write it down. You'll see it in a while. So x can be equal to 1.65. Here, the other possibility is 7.09. Okay, and the last one here is 19.26. Okay, so if we go back to our question here, these are the three answers we got. So it looks like we can create more than one box. Okay, so if we take 1.65, so we'll have, number one is going to be a height of 1.65. In this case here, it's centimeters. Okay, then my width is going to be 20 minus 2 times 1.65. Calculate that in a second. Okay, in fact, let's just do it now. Let's get our calculator out. Okay, so here we've got 20 minus 2 times 1.65. Okay, so there's 16.7. And lastly, we have the length, which is 18 minus x, so 18 minus 1.65. And so that's going to be about 16.4. All right. So now we do the same thing. Oh, sorry, there you go. So you can see that. We'll do the same thing with 7.09. So our second possible box, so we've got a height of 7 point, you know what, I'll just do it to one decimal place. So 7.1 centimeters. Then the width is going to be 20 minus 2 times 7.1. So let's calculate that. 20 minus 2, 20 minus 2 times 7.1, so that's 5.8 centimeters. And let's do the length, which is going to be 18 minus 7.1, which is 10.9 centimeters. All right, so now we have one more, the 19.26. But I hope you're going to see that I'm not going to bother with the 19.26 because x can be equal to 19.26, not a problem. But when I try to input this value into either the width or the length, we see that it results in a negative value. So while this solves our polynomial equation, what it does not do is solve the problem at hand. All right? So just to recap, step number one, because I was going to be working with the volume of a box, I needed to find expressions to represent the 3 dimensions of this box. Okay, so I needed to determine that based on the diagram and the explanation given. And then once I had the volume, I was able to input the specific volume and solve the equation. In this case here, I needed to use technology. All right, and just before we go, I will show you another option. An alternative to Desmos is, if you type in equation solver, if that's what you're trying to do, and you'll notice here, I always suggest using Symbolab. And here, you don't even have to worry about bringing anything to the other side. I'm just going to write the equation exactly as it is. X times 18 minus x times 20 minus 2x, okay, equals 450. And all you have to do is press go. And lo and behold, it will give you the answers. So those are the same answers we found on Desmos. All right. So this is another alternative you should be considering when you need to use technology. All right. That's it for this one.